All right, let's dive right in. Over the next few minutes, we're going to build, from the ground up, a complete picture of how blockchain is totally set to revolutionize our energy markets.
I mean, just imagine this for a second. This isn't some far-off science fiction. This is the vision of a real peer-to-peer energy market, where you're not just a consumer, you're a producer, selling power directly to your neighbors. It's a huge shift from the old centralized grid to a brand new decentralized marketplace.
Right, so that's the big question, isn't it? How on earth do you manage this incredibly complex dance of energy moving back and forth and keep it all secure and transparent? The traditional systems we have, they just weren't built for this.
You see, our energy world is changing, and it's changing fast. It's becoming more local, way more digital, and way more decentralized. And a new world like that, well, it needs a completely new kind of operating system.
I mean, really think about it. The old platforms just can't keep up. How do you verify millions of tiny little transactions from every solar panel and every electric car? How do you stop somebody from tweaking the data? And how do you let neighbors trade directly with each other and keep a perfect, trustworthy record of it all? It's a massive challenge.
And this is exactly where blockchain steps onto the scene. It brings a direct solution to every single one of those problems. It gives you trust without needing a big company in the middle, it creates records that are basically impossible to tamper with, and it automates the whole thing securely.
Okay, so to really get how this all works, we've got to start small. We need to break it all the way down to the smallest, most fundamental piece of the whole system. Let's talk about the transaction.
A transaction is just a record of a single trade. That's it. It's like the single atom in this entire structure. Absolutely everything we build from here on out is designed just to protect the truth of these simple little exchanges.
And you know, what's so cool about this is just how simple it is. At the end of the day, a trade just needs to know who's buying, who's selling, how much energy, for what price, and when it happened. The whole point of this incredibly sophisticated system is just to guarantee that this one simple record is true and permanent.
So, we've got all these individual transactions. Now what? Well, you can't just leave them floating around in cyberspace, right? You've got to package them up into secure containers, and we call those blocks.
We call these secure packages blocks, but a block is way more than just a list of trades. You should think of it more like a digital strongbox. It holds a whole batch of verified transactions, plus some really important data that locks it all down.
So, inside each of these strongboxes, yeah, you've got the trades, but you've also got some other critical info. There's a timestamp, obviously, but then there are two key security features. A hash, which is the block's own unique digital fingerprint, and the previous hash. Now this is the magic part. That's the fingerprint of the block that came right before it. That link is everything.
And that little piece of data, that previous hash, that is how we forge this unbreakable chain. We use cryptography to literally link these blocks together, one after the other, creating a structure that's not only secure but also impossible to secretly change.
Here's how it works. It's actually pretty simple. First, a block gets created, and it gets its own unique hash, its fingerprint. Then, when the next block comes along, it has to grab the hash from the block before it and bake it into its own data. This creates this incredibly strong dependency. Because if you try to go back and mess with that first block, its hash changes, right? And boom, the link to the second block is instantly broken. The entire chain would shatter, and everyone would know.
I love this analogy. It's just like a digital notebook, where every single page is sealed to the one before it with this super strong cryptographic glue. You can't just sneak back to page 10 and change a number without breaking the seals on page 11, 12, 13, and every single page after that. It makes tampering obvious. So the tech that makes these digital fingerprints is called hashing. It uses an algorithm that basically takes all the data in a block, all of it, and runs it through a mathematical function. Out pops a unique code. You can't ever reverse it to get the original data back, and most importantly, it's ridiculously sensitive to even the tiniest change.
Okay, get this. This shows you just how powerful that is. On the left, there's our original block with its hash. On the right, look, all we did was change the energy amount by a tiny, tiny fraction of a kilowatt hour, something you'd never ever spot. But look at the hash. It's completely, wildly different. It's not even close. This is what makes any attempt to cheat so glaringly obvious.
All right, so now we have the pieces. We have transactions, we have secure blocks, and we have an unbreakable chain. So let's put it all together and see what a real functioning energy market would look like using this tech.
A round in this market basically happens in 3 quick steps.
First, everyone who wants to participate submits their orders. I want to buy this much. I want to sell that much. Second, a clever little engine finds the perfect price that balances supply and demand and matches everyone up. And third, all those completed trades get bundled into a new block and are securely added to the chain for good.
So how does it find that perfect price? Well, it's classic economics, really. You just take all the sell orders and plot a supply curve. You take all the buy orders and plot a demand curve. And right where those two lines cross, bam, that's your market clearing price. It's the fair price for everybody in that specific round of trading. So once that price is locked in and the trades are matched, that's it. They're final. They get verified, sealed up into the next block, and are ready to become a permanent part of the market's history.
And this is what it looks like at the end of the day. You start with what's called a genesis block. That's block 0, the very beginning. Then, after your first market round, block 1 gets tacked on, filled with all those trades. Then comes block 2, then block 3, and it just keeps growing. A perfect, chronological, and completely unchangeable history of the entire market.
So, when you boil it all down, blockchain really has these 3 superpowers that make this whole thing possible. First, immutability. The record can't be changed. The past is the past. Second, consensus. Everyone on the network agrees on what the one single source of truth is. And third, decentralization. There's no single boss, no single company in control. And that is precisely why this technology isn't just some interesting experiment. It's becoming the actual, essential backbone for the smart, local, decentralized energy grids that we're all moving toward. It provides the trust we need for this new world to work.
So I'll leave you with this to think about. If your own home, your car, your battery, if they could all actively participate in a local energy market, what would that really unlock for your community? What kind of new services, new businesses, and new initiatives could be built on top of a system like this? The possibilities, well, they're just beginning to unfold.